Okay, so in the last clip, we went through how to generate the forecasts, right? The purchasing of each model of purchasing power parity forecast, the uncovered interest parity forecast, and the naive forecast. Then we took the error of that forecast. Again, that's just as this function bar shows. That's the actual value minus the forecast value. And then we're going to square those errors. And in this clip, what we're gonna do is we're gonna evaluate these forecasting techniques: the purchasing power parity, uncovered interest parity, and naive. We said one way to do that is to calculate what's called the root mean squared error. So I'm going to write RMSE here for root mean squared error. And what is it? It's a number that you want to minimize. It's a type of error. So you want to pick your models based on which model, which forecasting techniques generates the least amount of error. Okay, we just transform it a little bit with taking the error squared. We do that so that the positive and negative errors don't cancel out, so we square it. And then we take the average forecasting error and then take the square root of it. Okay, just the name implies. So root, so that's square root. Mean, we're going to take the average. Average of what? Of the squared errors. So that's what we'll do here. So equals, from the last clip, we already squared our error. So that's already been done. So we just need to take the square root. Square root of what? Of the average, parentheses, of what? Of this whole column. Okay, I can highlight it with the mouse and drag it, or I can just type it in if I know the cells. So then we need to close off the average parentheses. See how it's red, then it turns red. And then the next one will be black to close off the square root parentheses. So enter. And so this is the root mean squared error. It's 0.07. Now this number doesn't really have any meaning per se, any inherent meaning. You say, what does that mean? 7.5%? It doesn't really have any meaning. We generally don't try to interpret it. What we do is we use it to compare. Again, we pick our the best forecasting techniques based on whichever one minimizes this value. So because we took that formula, we can do the same thing here: square root, average, or again, if we wanted to be, I think it's faster at least, is to take the formula that we used here and just, instead of dragging and dropping down, we can drag and drop, so to speak, to the right. Right? So now we have our root mean squared error for the uncovered interest parity and for the naive forecast. The square root, taking the square root of the average of this column and of this column is essentially meaningless, so we can get rid of those. Same thing, uncovered interest parity error and uncovered interest parity implied. Look what we did here. We took the square root of the average of these values. That's meaningless. We can delete that. Square root of the average of this column, again, not really meaningful, so we delete that. And we have our root mean squared error for the three forecasting models. Notice that with purchasing power parity implied, we're missing a forecast. Uncovered interest parity and naive forecast have one more value than purchasing power parity implied. But that's okay. That's not a big deal. We have 133 observations here, so purchasing power parity is just one less than the other two. That's not a big deal. So with these three in mind, we can now judge which forecast is better, and you see which one's smaller. 0.073 is less than 0.075. 0.08 is the highest, of course. So again, from these three, just like we showed in class, this example corroborates what I said in class, is that the naive forecasting method, again, that's just the 8th grader's technique of forecasting, beats the other two models based on this root mean squared error number. So in the next clip, I'll show how to evaluate the forecast techniques with using the graphs.